Hello. Today we are going to solve this question, starting with part A. Given A equal the following fraction, and part A prove that A equals 5. So before we start, I just want to remind you with some notes that whenever we have, for example, A power m all to the power n, and this is related to the power rules. So A power n all to the power m is A power m times n. So we multiply the powers. For example, 3 power 2 all power 3 is a 3 power 2 times 3, which is 6. Also, if we have A power n times A power m, so this is the first rule, this is the second rule, in which we have the same base. So it is A power n plus m. For example, 2 power 3 times 2 power 5 equals to 2 power 3 plus 5, which is equals to 8. This is the second rule we want to remember. And of course, whenever we have a fraction and negative powers, for example, A power, for example, minus 2 over A power 3, let's say. So in order to get rid of this negative power, we move it downwards. So if it is in the numerator, we move it to the denominator. For example, this will become A power 3 is a positive power, so it will stay in the denominator A power 3. A power minus 2, it's a negative power. In order to get rid of this minus 2, we move it downwards. We move it in the opposite direction. If it is up, we move it to the denominator. So it will be A power 2. And of course, above nothing remains, so 1. If it is in the denominator, let's say A power 2, A power minus 3, then we move it upwards. So A power 2, it stays in the numerator, times A power 3, we move it upwards, we get rid of this minus, we just write it A power 3, and nothing will remain in the denominator. So these are quick examples. Now try to pause the video and solve A. Okay, so we have many ways to solve this equation, but to make it easy, I'm going to use or to follow these steps. So first of all, I will decompose. Step 1. Step 2, I will group these numbers having the same base. I will group them. And the third step, I will factorize, like cross from above and below. Okay, so 25, we can, if we do not know it, we can use the prime factorization, but it's easy. 25, it is 5 squared times. Now, I said I want to decompose, but for 10, okay, because we have 10 and 10 and 10, and here a 10, so I will keep it as it is. I will just group it, okay, so just only for 10, because it's much easier like that. So 10 power 4, 10 power 6, 10 power minus 1, they will be 10 power 4 and the 10 power 6, so we can remember that they have the same base. 10 power 4 and 10 power 6 and 10 power minus 1 and 10 power minus 1, they all have the same base, so I just add the powers. They are 10 power 4 plus 6 minus 1. They are 10 power 4 plus 6, it's 10 minus 1, so they are 10 power 9. So here 10 power 9 times 5. I cannot decompose 5 anymore because 5 is a prime number. Now 25, it is 5 squared, and 10 power 3 all power 3, so we said that whenever we have parentheses we multiply these powers, so it is 10 power 9. Now I just want to cross. I finished grouping them. Now I want to factorize. Okay, so 5 squared, I can factorize it with 5 squared, like I divide by 5 squared above and below, or I just cancel them. And 10 power 9 and 10 power 9, so my answer will be 5. And here's what they asked me, A equals to 5. So we want to solve this one and see if it will, if the answer will be equals to minus 1. Just I want to remind you with some notes. So whenever we have two fractions, I want to subtract them or I want to add them, for example. So I just follow these rules. So if I have 1 over 2 plus 3 over 2, they have the same denominator, then I can add them. So I add the numerators, which is 4 over 2, and then I can simplify, the answer is 2. But if I have different denominators, for example 1 over 2 plus 1 over 3, so 2 and 3, they are different denominators, and here I cannot add them. So what I want to do, I want to multiply the denominators by each other. So times 3 times 3 times 2 times 2. So I multiplied the first fraction by the denominator of the second one, and the second fraction, which is 1 over 3, by the denominator of this one. Okay, and then I will get the answer. I multiply, and remember, I multiply in the numerator and in the denominator. So 3 over 6 plus 2 over 6. Okay, and now if they have the same denominator, I keep the denominator as it is, and then I add. The same rule applies if I have a minus here, so it's the same, I should have same denominator. Okay, so and also I want to remind you, if we have times and division, it's not found here, but we will remember it. So if we have 1 over 2 times 1 over 3, no same denominator is needed. We just multiply the numerator by the numerator and the denominator by the denominator. If I have something to cross and simplify, I will do that in this step, but if I don't, I just multiply by each other. And if I have division, or the divided sign, okay, then I will skip the first fraction, 1 over 2. This division will be times, and write the reciprocal of 1 over 3, which will be 3 over 1. And whenever I reach this step, which is multiplication, I multiply normally like I multiplied here. So the numerator by the denominator and the denominator by the denominator, it will be 3 over 2 here. Okay, so here are all the operations and how we add them as a fraction. One more note, if I have a complex fraction like a over b and c over d, we have agreed that the quickest way is to multiply the furthest by the furthest. They are far apart, okay, and the closest one by each other. So first of all, I multiply the farthest one, so a times d over b times c. So first these, the far apart numbers, and then in the numerator I write them over b times c. Okay, so pause the video and try to solve b. So if we want to solve it, first of all we start by doing all of this stuff in the numerator, and then we do all of this stuff in the denominator, and after that we will obtain a complex fraction, a fraction above all of these. We will turn them into one fraction, and all of these we will turn them into one fraction, and we have this main dash in the middle, and then we will do the farthest by the farthest and the closest one by the closest one. Okay, so our first step, we are going to solve these ones. If we want 3 minus 1 over 2, so 3 I will put it over 1, and if they have different denominators, then I multiply 1, I multiply it by 2. No need to multiply by 1 here because we will obtain the same answer. And also over 1 and multiply it by the denominator by 2, also no need to multiply by 1. Okay, we'll obtain the same answer because. So whenever we multiply them, 3 times 2, it will be 6 over 2 minus 1 over 2 over, okay, I'm sorry. So you see, this type of writing is wrong because this main dash should be on the same level of the equal. So you see the equal, the main dash, then the equal, the main dash should be on the same level. Okay, so I will correct that. This main dash here, okay, and I will write 6 over 2 minus 1 over 2, and here 6 times 2, 12 over 2 minus 17 over 2. Now whenever I have same the denominator, so the denominator of this is 2 and 2 and 2 and 2. No need for these to be the same denominator, no need, just for these ones. Okay, here by chance in all of them they have the same denominator, but what's important is the denominator of these two fractions that I want to subtract them. Okay, so 6 minus 1, I will obtain 5 over 2 minus 12 minus 6, Okay, pay attention here. So we have 12 minus 6, a small number minus a big number. So if this is the sign a plus, so 12 it's a positively sign, but we don't write plus. So different signs, I write the sign of the greatest, which is minus, and I subtract 17 minus 2, it will be 5 over 2, negative 5 over 2. And now I have reached my goal that I have a fraction, main dash, a fraction. Now I multiply 5 times 2 and 2 times 5. Okay, so I write 5 times 2 over 2 times minus 5. Okay, and in this step I can either multiply them and then simplify, but the easiest way for me is to just simply simplify them. Okay, so no numbers are obtained in the numerator, so 1. No numbers are obtained in the denominator, but pay attention to this minus, so it is minus 1. Okay, and 1 divided by minus 1, so it's positive, divided by negative, it's negative 1. Okay, so part C, we are asked to calculate C. Now in order to calculate C, I should know the following note, which is the order of operations. So whenever I have different operations, like we have minus, we have division, or in sometimes we have more than that, we should follow these order of operation rules. So first of all, I do the parentheses. So if I have, like for example, if I have parentheses here, I should ignore everything and go inside the parentheses and solve what's inside of it. Second, if I have exponents, also, so after I finished my parentheses, I go to my exponents, and after I finish my exponents, I go to division and multiplication, and that is from left to right. So whenever I see a multiplication sign here and a division sign here, I solve the first one here. So from left to right, and addition and subtraction also from left to right. Okay, these are my order of operations, I should follow them. So if I don't have parentheses, then I skip that. I go to the exponents. I do not have that, I skip that. Then I go to these two signs in this example here. Okay, so pause the video and solve it alone. Okay, so when we are going to solve it, I will see first my operations. What are the operations found here? I have subtraction and division. According to order of operations, parentheses first, I do not have parentheses, exponents, no exponents, multiplication and division. And yes, I have division. So I skip the 5 minus and then I go directly to these two fractions. I want to divide them because division is before subtraction. So this 5, I copy it as it is, the minus, I copy it as it is, and then I want to divide. So how to divide 10 over 2 divided by 5 over 4? So whenever we have division, I copy the same fraction as it is, and then I do what I like to call skip, flip, and multiply. So skip the first one and flip those. The division becomes multiplication, and I write the reciprocal of 5 over 4. It will be 10 over 2 times 4 over 5, the reciprocal of that. Okay, and now how to multiply? So I'm copying 5 the same, okay, and then I multiply 10 times 4 over 2 times 5. Now in this step I can either multiply directly or I can cross if I have something in common, and I have something in common here. So 4 and 2 I can divide by 2 above and below. So if I can divide by 2 below, it will be gone, and I will have 2 remaining from this 4, and I can divide by 5 here. Both are divisible by 5, so if I divide 5 by 5, nothing will remain here, and 2 will be remained here. Okay, so I can write those 2, and I can keep them in my memory. So 5 minus, so 2 and 2 are remained from what I have simplified here, and 2 times 2, it will be 4 over nothing over 1, then no need to write it. And now I should subtract 5 minus 4, it will be 1. So see, it is 1. So in part 2C, the question is deduced that B and C are opposite numbers. So from part 2A, in part 2A we have calculated that B equals to minus 1. And in part 2B we have calculated that we have calculated C and our answer was 1. So are they opposite numbers? So yes, B is the opposite number of C, so we say that then -1 is opposite to 1, +1. Okay, then B and C are opposite numbers. So the third part, we have calculate radical A times 10 over 2 plus B squared minus C. So we want to calculate this expression. We got our answers, which is A equals to 5, B equals to -1, and C equals to 1. We just put them in this expression. So radical, instead of A we take it and we write 5 times 10 over 2 plus B squared, it is -1, all squared, minus C, it is 1. So radical. Now we want to simplify this expression. So 10 over 2, it is 5. So we have 5, and 10 divided by 2, if we want to simplify, we have from this 10 5 remain. So 5 times 5 plus -1 squared. So because this exponent is even, then the minus will go. So -1, or you can think about it as -1 times -1. So minus times minus, it's a plus, and +1 -1. So we have radical 5 squared plus 1 minus 1, it is equals to 0. So the answer is 5.